My name is Glenn Sizemore and I'm a technical marketing engineer here at NetApp. Today I'm going to be showing you our rapid provisioning capabilities that we have for Hyper-V. And today's demo is going to be using our Sub-LUN cloning technology that shipped as part of the on-command plugin for Microsoft version 3.0. So here we have our SCVMM environment. We have a single cluster with 8 nodes and a handful of virtual machines. Now normally to deploy a virtual machine, you'd go ahead and click this new VM wizard, but to kind of highlight our rapid provisioning capabilities, I've wrote a fairly simple PowerShell script. Now we're not going to go through the script, I just want to highlight the fact that we're using the System Center Virtual Machine Manager, Data on Tap, and on-command modules to actually do this rapid provisioning. Now to hit go, we just call it, give it a base name, and tell it how many VMs we want, and it'll do the rest. But first, to get a feel for what we mean by rapid provisioning, I need to do one the old way. So let's go through and pick our template. We're going to use the same template in our rapid provisioning. We'll give it a name, standard. And we're not going to change anything. We're just going to accept the defaults here. We're going to let SCVMM pick which host. Yes, I want it to be clustered. We're going to use that same integration. Yes, pick a network. We're going to use that same integration for intelligent host selection in the script, and we'll see that as it runs through. We want it to start and create. Now right away, SCVMM is going to open up the jobs pane, and we're going to see that the actual virtual machine is deployed almost instantaneously. The longest poll in this deployment process is going to be 1.2, while it's actually streaming those bits from the SCVMM server to the destination cluster. So here it says it's going to take about 5 minutes, so we're going to hit go on our script now. And we go through, and just as I explained before, first steps first, we're going to contact the SCVMM server. We're going to find that template. Here you can see the Win2K8R2 template, the same template we used. We enumerate that target cluster, that same Hyper-V cluster, and then we go do some intelligence on the back end. We just do some deep integration with the storage layer to find out exactly what the best fit's going to be, not only from a compute but from a storage standpoint. Open that back up. Move this over so you can see it a little better. You can see we've already done all that. We've found that Hyper-V 3 is the best fit, and we've started the clone operation on our first virtual machine. And there we go. We deployed our first VM in 21 seconds. And we immediately go back into the loop, and we start enumerating. We find Hyper-V 3 is still the best fit, but now Volume 4, whichever CSV that is, Volume 4 is now the best fit for the VHD, so we're going to clone into that storage instead. And we see, there we go, 19 seconds. So we're going to let that run in the background for a second and just kind of explain what's going on behind the scenes, what's enabling that insane speed that we just witnessed. So here I have a logical breakout of that physical environment that we were just viewing. On the top is the environment as seen by the Windows host. On the bottom is the environment as seen by Data on Tap and our NetApp controller. On the left-hand side, this is our source LUN with the VHD contained inside it. And then on the right-hand side is the destination CSV in the Windows cluster that we're actually going to be deploying the new VM into. So what we do is we start by querying NTFS on the source server and saying, NTFS, please give me the block range of the following file. And then NTFS returns back with all the SCSI LBA ranges for all the file fragments, for all the segments, file segments that actually make up that VHD. We then take that information and correlate that to what's physically been implemented on the controller, right? So we do the mapping from NTFS to the blocks in Waffle. We then go to the destination and we create a new VHD. Now, when we create the new VHD, we don't do any allocation, right? We don't write any zeros, we don't write footers, we don't do anything. We just make sure the file is the same exact size as the source file. We then go to NTFS and we say, NTFS, please give me the SCSI LBA range for that file. NTFS returns back with the collection of ranges. We then take those two ranges and we pass a single command to the controller and we say, Data on Tap, please clone the following blocks to the following blocks. And Data on Tap in turn mirrors that data for us and we're left with a mirror copy. Now, what's unique about what we're doing here is as long as the source and destination LUN is in the same volume on the controller, this isn't copy offload. We're not just removing the network from the equation. We're removing the copy. So to explain how we actually do this, I've broken down this environment even further. Here again, we have the host view on the top and the storage view on the bottom. Our source and destination VHDs. Only here I've explicitly drawn the linkage from the blocks inside NTFS to the physical blocks inside Waffle. When we pass that sysclone zappy, what's actually happening is data on tap is just moving pointers. Right? We're not actually copying the data. We're just taking that block and saying, hey, when you ask for this block, I'm going to return with the data from this block. Now, mind you, this is not a read-only copy, right? This isn't a link clone or anything like that, right? There's no snapshot here. We've literally just manipulated the inodes to point to the data that we want. So when you write new data, when there's actually unique information written to the new VHD, we do write a new block. We don't overwrite. We just swing that link again. Now, as for the old blocks that were allocated, just like any information inside Waffle, there's background processes that run, and they're going to eventually be deallocated and pre-zeroed to maintain that write performance that we see. So the takeaway here is not only are you able to deploy a VHD in seconds, not minutes, but they're actually pre-deduplicated. Right? Because we didn't write new data, because we were linking to an existing block, we never actually allocate anything on the controller. So your dedupe ratios, right, without even running dedupe, you're going to see sys savings. It's really fantastic stuff. So now let's flip back over and check in on the status of our deployment. Here we see that SCVMM is almost done deploying its virtual machine. And so far we have deployed 14. We'll probably get the 15th VM in before this is over. But more importantly, notice how the virtual machine deployment times have stayed consistent. We're dealing with sub 20-second deployments each time around. It's really impressive. It just does not slow down. We can maintain this speed regardless of the number of virtual machines. So now that this is done, we're going to, yep, it's almost done there. So let's flip over to SCVMM and we'll just see those virtual machines, and you can see that they're all in various stages of their post-sys prep and deployment process. Finally, let's go ahead and fast forward to the end of this. We said we were going to deploy 200 of them, so let's go all the way to the end. Here we are. It's fast forwarded about 55 minutes. We can see that 198, we're deploying 199 right now. And again, the speeds just, they haven't changed. We're consistently pumping out a virtual machine between 15 and 25 seconds apiece. And there's the last one, number 200. So we started at 7:58 p.m. and we finished at 8:57. So that's less than 1 hour for 200 virtual machines. In here you can see all the VMs and the ones that are still in the sysprep process. And just to prove to you there are no tricks here, we did actually clone a virtual machine. Let's go ahead and we'll connect to the console on one of them. And there you have it. Windows Server 2008 R2 fully deployed. I'd like to thank you for your time. I hope you enjoyed our presentation. And as always, to stay up to date with everything going on in the NetApp Microsoft ecosystem, head on over to blogs.netapp.com/msnviro.